Section 4.1 Basic Concepts of Probability. An event is any collection of results or outcomes of a procedure. A simple event is an outcome or an event that cannot be further broken down into simpler components. The sample space for a procedure consists of all possible simple events. That is, the sample space consists of all outcomes that cannot be broken down any further. For example, if I roll a die, my sample space is a set of 1, 2, 3, 4, 5, and 6. These are all of the possible outcomes when I roll a die. An event is any combination of these numbers. So an event can be even numbers, can be odd numbers, can be 2. A simple event is an event that cannot be broken down any further. For example, 2 or 5 or 3 or 1. An event of even number is not simple event because even number can be broken down into 2, 4, and 6. Odd number cannot be considered as simple event because odd can be broken down into 1, 3, and 5. 2 is considered as simple event because 2 cannot be broken down any further. The same thing with 5. The notation for probabilities. P stands for probability. Any uppercase letter denotes a specific event. P of A denotes the probability of event A occurring. The possible values for a probability is from 0 to 1. If the probability is 1 or close to 1, that means it's certain or likely to happen. If the value of the probability is 0 or close to 0, that means it's impossible or unlikely to happen. If the probability is 0.5, that is 50-50 chance. Probability of any event is always in between 0 and 1, inclusive. That means the probability can be 0, or the probability can be 1, or any number in between 0 and 1. There are 3 common ways to find the probability. The first way is when we use the relative frequency approximation of probability. Conduct a procedure and count the number of times that A occurs. P of A is then approximated as follows. The number of times A occurred divided by the number of times the procedure repeated. Classical approach to probability. If a procedure has n different simple events that are equally likely, and if event A can occur in s different ways, probability of A equals to the number of ways A occurs divided by the total number of elements in your sample space, which is S over n. Subjective probabilities P of A. The probability of event A is estimated by using knowledge of the relevant circumstances. Rounding probabilities. Whenever you are working on a homework problem or any assignment, the first thing you are going to do is read the instruction. If the instruction tells you to round to 3 decimal places or 5 decimal places, then please follow the instruction. If the instruction is not given, then you can either give exact fraction or exact decimal. or you can round off the final decimal to 3 significant digits. For example, instead of 2/3, you can round it to 0.667. Law of large numbers. As the procedure is repeated again and again, the relative frequency probability of an event tends to approach the actual probability. Example 1. In a recent year, there were about 3 million skydiving jumps, and 21 of them resulted in deaths. Find the probability of dying when making a skydiving jump. The total number of people who make skydiving jump is 3 million. The total number of deaths in these 3 million is 21. I'm looking for probability of dying when making skydiving jump. My event is dying when making a skydiving jump. In order to find the probability of dying when making a skydiving jump, I take the total number of deaths divided by the total number of skydiving jumps, which is 21 over 3 million. When you take 21 divided by 3 million, your calculator gives you this. You have to know how to read this scientific notation. 7e negative 6 means 7 times 10 to the negative 6, which means you are going to move your decimal point to the left 6 places. So your decimal is 0.00007. In a study of U.S. high school drivers, it was found that 3,785 texted while driving during the previous 30 days, and 4,720 did not text while driving. Based on these results, if a high school driver is randomly selected, find the probability that he or she texted while driving during the previous 30 days. So my event is that the person texted while driving. So I have 3,785 texted while driving, 4,720 did not text while driving. The total number of drivers is 3,785 plus 4,720, which is 8,505. And I want to find the probability of a driver texted while driving. I am going to take the total number of drivers who texted while driving divided by the total number of drivers. Which is 3,785 divided by 8,505. So what I got is 0.4450323339. If you are working on this problem on a homework, please read your instruction to see how many decimal places that you want to round. Now, there were no instruction here, so I'm going to round it to 3 significant figures. Which is 0.445. Complement. The complement of event A, denoted by A bar, consists of all outcomes in the event A that does not occur. For example, if I roll a die, my sample space is 1, 2, 3, 4, 5, and 6. Say I have an event art. The event art will contain 1, 3, and 5. The complement of art is art bar, which is a set that contains the value in the sample space but not in art, which is 2, 4, and 6. In another word, complement of art is even. The event and its complement will not share any element. In this set and this set, we don't have a common element. Example 3. In a recent year, there were 3 million skydiving jumps and 21 of them result in death. Find the probability of not dying when making a skydiving jump. So my event is not dying. I want to find the probability of not dying. Not dying is the complement of dying. So basically I can find the probability of dying with a bar on top. So the rule of complement is that if you want to find the probability of the complement, you can take 1 minus the probability of the event. Remember that we found the probability of dying in the previous example, so we just substitute that in here. And we get 0.99993. Example 4. Refer to the sample data of polygraph test shown below. Did the subject actually lie? I have the first column recording the number of people who did not lie. The second column recording the number of people who actually lie. The first row recording the number of people who have positive test result. The second row recording the number of people who have negative test result. Whenever I'm given a table like this, what I'm going to do first is always find the total for each column, each row, and then the grand total. 10 plus 30 is 40. 43 plus 10 is 53. Ten plus 43 is 53. 10 plus 30 is 40. I have total of 40 people who did not lie. Total of 53 people who actually lie. 53 people have positive test result. 40 people have negative test result. How many people do I have in total? I'll take 53 plus 40, which is 93. We call this 93 is the grand total, which is your sample size. Most of the probability problem will be divided by this grand total. Question A. If one of the test subjects is randomly selected, what is the probability that the subject is not lying? My event is not lying. So I'm looking for the total number of people who did not lie, which is 50. Which I am going to take the number of people who did not lie divided by the grand total. and I got 0.430,107,5296. There was no instruction to tell me how many decimal places, so I am going to round it to 3 significant figures. B. Is the result close to the probability of 0.430 for a negative test result? So in order to consider if the probability are close or not, we are taking the difference in between the two probabilities. So we're going to take the larger probability, subtract the smaller probability. After we found this difference, we are compare this with 5%. So this is less than 0.05. So the answer is yes, this result is close enough because the difference is less than 5%.